How are you?
Pretty much.
You have intermittent stuff.
That's not good.
I don't know. Well, main thing is what you will be doing on your on your stations.
Okay. Okay. Oh, okay.
So it's basically.
Okay, sounds good.
So you may guess what we are going to do globally for like. Do you have any guesses? What will be our plan for like next month in the course?
Using Gaussian.
Yes, it is for the scientific part, for actual skills. But administratively, how are we going to arrange our interactions?
Presentation.
Yes. So you'll sign up maybe tomorrow in class, and
Next round of presentations that soon? Next round of presentations that soon?
our life is not too long. Well, I screw up the date. 01/01/18 is of course not correct. It is in the past. It should be 03/01, like March 1st.
Okay. Okay. Yeah. I mean, I guess we're going to miss a whole week, so it makes sense. I guess we're going to miss a whole week, so that makes sense.
Yes, if we wouldn't go to a conference, we would do it earlier, 1 week earlier or even 2 weeks earlier. So we need 3 labs before we go through and get enough skills for making these presentations. And you can see the list of things that that we are going to do. I'll probably pick up the easiest ones, at least to start with, and then we'll go into the details. So, what are we focusing on? What is our goal before we go to practical skills? The goal is to forget about geometry and focus on electronic properties. So we will refresh in our memories what are electronic properties that you can recall or design or imagine. And very, very simple practical skill. Run so-called single point electronic structure calculation and analyze the results. For the very, very first steps, we'll do it graphically, and then very soon we'll do everything in which mode?
Command line?
Yes, correct, in command line. So which? Please glance through this list.
Doing all right? All right.
Very good, thank you.
Is Braden out here?
I don't know. I messaged him and he hasn't responded.
Don't change up the order now, though.
What's up?
Don't change up the order now.
Right.
We want to run single point electronic structure. Single point means we do not move positions of ions.
Okay.
And if you look through, you will recognize something, but I will skip some important and go to just most fun and pleasant aspects. Which molecule we will start with? So we We are not going to theoretically consider something. You need a practical example. And in your homework that you have submitted, you did some oligomers of titanium dioxide. But we can start with the simplest form of titanium dioxide, with like monomer of single titanium coordinated with 4 hydroxyls. Titanium hydroxide. It is not very stable because it will start nucleating into bigger particle if you prepare it in the liquid phase. But for our purposes, it is beneficial. It is beneficial. Why? Because of 2 reasons. First, it is very small. So 1 titanium, 4 hydrogens, and 4 oxygens, so 9 atoms. But it is smaller than many hydrocarbons. But it is one of the simplest possible inorganic compound, or something related to inorganic, so that we will immediately train skills that are applicable to broader range of materials. Because if we start learning from hydrocarbons, many things that will work for them will not work for inorganic things. So prepare or take from your depository, from your homework preparation, monomer, titanium hydroxide. Do not optimize geometry. Run single point calculation. I will prompt which it will be not keywords. We will prepare input file from the Gauss field, and then upon submitting the job into the queue and completion, there will be output file that we will analyze. Okay. Prepare model, prepare tasks, what to compute, and then submit to the queue, and then analyze results. So if you are using your own system, then you may have already set up an X connection. If you didn't, the system here already have X connection for sure, in the form of X term, or I did double check that MOBA X term doesn't need any system privileges. You just go to the website, download and run. It will run. So I assume that all of us do have access to Gauss U on the remote supercomputer. If you don't, let me know, I will assist. Which row of periodic table should we look for titanium? I thought 3rd, but in this table, by some reason, it is 4th. But you can just so when you I believe that you can do everything yourself, but I will just go around and make sure that we are on the same page.
Gauss.
Yeah. Alan told me to do that until I can find a fix.
So that's what I typed in. What it was.
So sequence on the desktop. You don't have to
Just gotta get Linux.
What's up is switching to a cute little extra.
Landon, I have to tunnel through Alan's computer to get to the cluster so I can view Gauss view because it doesn't work on Mac for me.
Wait, what?
Remember those random little pains in the ass that I was talking about? They come with owning a Mac.
This is the only one I've run into so far.
Really?
Yeah.
It's like literally every time I try to do anything on there, like actually computational or like actually using the computer.
So you guys have Mac, right? You have X.
Yep.
What?
Well, I'm running Ubuntu on my Mac.
Oh, what?
A different.
Yeah, a version of Linux.
He's not using that.
Yeah.
Do you have cords?
Oh Jesus. Yeah, I have X quartz.
Okay, so
You might have to update it because I know mine was way out of date when I tried to.
Mine's up to date and it still doesn't work.
Yeah, mine's up to date too. Did you like find that file that Russell was talking about during his presentation?
Yeah, I did, and I tried to change it and it still didn't
How
work.
did you find it? Like, what was it under?
It might be in one of your files that Mac just decides to hide, like just that file.
Yeah. So basically,
Is it in one of the library files? Do you know, BJ?
just do CD. It's like in the